Hello there, Mr. Sutton here, bringing you the Algebra 2 2-2 Part 1 homework solutions on characteristics of quadratic functions, this one dealing specifically with vertex form. For this problem, we're trying to graph the function f of x equals x minus 3 quantities squared. Since this is in vertex form, it'd be pretty, actually, I guess you could call this intercept or vertex form, but either way, it'd be pretty easy to get the vertex out of this thing. Since we have a minus 3 in here, the x value of the vertex is going to be 3. There's a plus 0 out here, so just 0 is the y value. So we have a vertex of 3 comma 0, and let me go ahead and graph that. So that's going to be right here. And now let me get 2 more points. To get one of these, I'm just going to take a point very close to this, like x equals 4 and whatever y value goes with that. So let me plug 4 in here. So we have 4 minus 3 quantities squared. That's just 1 squared, or 1. So that gives us the point 4 comma 1. And then I can just use the axis of symmetry that goes through the vertex and reflect that point over to the other side. So then I graph the parabola through those 3 points, and I'm done. On this problem, we're trying to graph the g function. I'm going to think of this as being in vertex form, although I could think of this as a standard form problem as well. It actually works better with vertex form, though. So there's an invisible x minus 0 quantity squared sort of thing going on here. So my x value of my vertex is just 0, and then negative 1 out here, this gives me the y value of my vertex. So 0 comma negative 1. Let me go ahead and graph that now. 0, negative 1 is right there. And now I'm just going to get another point by plugging in an x value very close to this, like the x value 1. If I plug 1 into this, that's negative 1 squared minus 1, which is just negative 1 minus 1, which is negative 2. So that gives me the point 1 comma negative 2. And then I can just use symmetry and reflect this over the axis of symmetry to get my third point. And then this gives me my parabola that I can draw. To graph this y function here, I just need to get the vertex and then get another point. So since this is in vertex form, I can just pick the vertex right out of there. So we're going to have a positive 7, because this is negative inside, and that's opposite of what we expect. So positive 7 comma negative 1 for the vertex. So graphing that out, we're going over 7, down 1 for that spot there. And now to get another point, I'm just going to plug in a number very close to 7, like 8. Plug 8 in for x. That's going to give me 1 squared minus 1, which is 0. So that's going to be 8 comma 0, which is right here. And then the axis of symmetry that goes through the vertex, I'm just going to reflect over that to get my third point right there. And then that gives me enough to draw my parabola through those. For this problem, trying to graph the g function, this is in vertex form, so let me start by getting my vertex. That's going to be based off the x plus 1, we have negative 1 for x. The minus 3 outside gives us minus 3 for y. So negative 1 comma negative 3. Graphing all that out, I'm going left 1 and down 3. There's my vertex. To get some other points, I'm just going to plug in an x value that's pretty close to negative 1. 0 is right next to that. That's a pretty easy one to plug in. So let me do g of 0. That's going to be 2 parentheses 0 plus 1 squared minus 3. 1 squared is just 1. We have 2 times 1 minus 3. That's just 2 minus 3, which comes out to a grand total of negative 1. So that gives us a second point of 0 comma negative 1. So over 0, down 1, right there. And then I can just use symmetry and reflect that point over the vertex to get this third point. And then that gives me my parabola, at least 3 points through which I can draw the parabola. For this problem, to graph y, this is in vertex form, so I'm going to start by getting my vertex. The x plus 1 inside gives me a minus 1 for the x value. The plus 3 outside gives me a plus 3 for the y value. So negative 1, positive 3. Going to my graph, we're going left 1 and up 3. There's my vertex. And to get a second point, I'll just plug in an x value that's pretty close to this negative 1 here. 0 seems like a pretty good one to plug in. So if I plug in 0 for x, that's going to give me 1/2, basically 1 squared plus 3. So just 1/2 of 1 plus 3. That's 1/2 plus, I guess you could think of this as 6/2. That would give me a grand total of 7/2 or 3.5, however you want to conceive of that. So we've got the point 0, comma 3.5 right here. And then I'll just reflect that over the vertex to get my third point right over here at -2, 3.5. And I can draw a parabola through those. On this problem, I'm trying to graph the y function. Since this is in vertex form, I'm just going to get the vertex first and then go from there. The x plus 2 inside means I have a -2 for the x of the vertex. Plus 1 outside means I have a plus 1 for the y. So -2, comma 1 is my vertex then, based off of this. Let me go to the graph. We have -2, comma 1 right there. Now I need 2 more points here. To get one of these, I'm just going to plug in an x value that's pretty close to -2. Like -1 seems to work pretty well. Let me plug in -1 for x. So we've got -1 plus 2 squared times -1/4 plus 1. We're going to have to do a little bit of work to get through this. So this is just +1 squared, which is just +1 that we're multiplying by -1/4. -1/4 times 1 is just -1/4. Add that to 1, and we have 3/4. So we have -1, comma 3/4, which is right about here. And if I just reflect that over the line of symmetry that goes through that vertex, I get another point here at -3, comma 3/4. Those 3 points give me enough to graph the parabola, and I'm done with this one.